At the review of those notes, those blank notes, the trigonometry stuff, sum and difference formulas. So here we go. Here we go, I said. Okay. So the first thing we're looking at is just the formulas themselves. And what we have are two different formulas, one for cosine of a sum or difference, and one for sine of a sum or difference. And then we'll look at going through some of the problems that you may have hopefully tried, taken a look at, or even seen the solutions. A couple of differences here. There are two major differences. For the cosine formula, it will always be the structure for any cosine of a sum or difference. Two cosines and then two sines. So you're always going to see cosine, cosine, sine, sine. That's always the way it looks for the cosine of a sum or difference. Another thing is the plus or minus in the formula. So if it's cosine of a sum, then you look around the top, x plus y, is always going to be a minus formula. And if it's the cosine of a difference, looking around the bottom, x minus y, that's always going to be a plus. So we get a switch of the signs here. Cosine of a sum is a minus formula. Cosine of a difference is a plus formula. Now for sine, we get a couple of different things. First of all, for every sine formula, it kind of switcheroos. So instead of being double cosine, double sine, it is now sine, cosine, and then cosine, sine. So we get a sine, cosine, cosine, sine. That's the first difference. The second one is, this time for sine, the signs stay. So sine of a sum is a sum formula. Sine of a difference is a difference formula. So we've got those differences. Let's go ahead and take a look at a couple examples. And again, you had already seen these, so let's see what we can do with this. We're trying to use the sum and difference formulas to find the value of the sine of 165 degrees. Now, we don't know this. This is not a chart value. And what you probably saw if you looked through the solutions already is that we can turn things that we know into this by working with formulas that we know. So having not just looked at it, I'm just going to go ahead and say, you know what? Here are the two numbers that I'm seeing. 165 is made up of 120 and a 45. So 120 plus 45 and 120, we know it's one of our nice angles. It's not first quadrant, but it's a good angle. So by our formula, sine of a sum is going to be sine of the first, cosine of the second. It's plus, it stays plus. So now it's cosine of the first, sine of the second. Now the sine and the cosine of 45, those are known quantities. This 120 degrees, take a quick look at where that is. 120 sits over here in quadrant 2. Reference angle is the 60 degrees. So to get sines and cosines of 120 degrees, the sine of 120 is related to the sine of its reference angle. Sine in quadrant 2, still positive. The cosine of 120 is related to the cosine of its reference angle, but cosine is in quadrant 2, cosine is negative there. So the values we get for sine of 120 is the same as the sine of 60, which is root 3 over 2. The cosine of 60, but negative, is negative 1/2. We now have everything we need, so we're going to come back here. Sine of 120 is root 3 over 2. Cosine of 45 is root 2 over 2, plus. The cosine of 120 is negative 1/2, and the sine of 45 is root 2 over 2. Recognize I'm going to get denominators of 4 for both. So this all over 4. Root 3, root 2, that's root 6, minus root 2. And that's going to be our answer here. Root 6 minus root 2, all over 4. Next. Problem a little different this time. We're given that angle x is between 0 and pi over 2. What does that tell me? That tells me that angle x is in quadrant 1. Y is also between 0 and pi over 2, so y is also in quadrant 1. Why is that useful? Well, it tells us all of our trig values will be positive, all of them. So now we have to go and figure out the sine of x plus y, and we've got a formula for that. So sine of x plus y is sine of the first, cosine of the second, plus cosine of the first, sine of the second. So what we need are sines and cosines of x's and y's. What we have is the cosine of x. Here's what I do. Draw a triangle. Here's angle x. The cosine of x, and we've done this before, long before we left, the cosine is adjacent, so it's 4 over 5. We know the missing side here, and that's 3. That means I can find everything we need about x. Let's do the same thing for y. Draw a y triangle here. This time what we know about y is the sine is 12/13. Here's 12 and 13. Little Pythagorean theorem here. It's the 5, 12, 13. Or go through and do a squared plus 12 squared equals 13 squared. So you can always use Pythagorean theorem. But it's 5. We're coming back here. So sine of x. Look at the x triangle. Sine is 3/5. Cosine of y. Look at the y triangle. That's 5/13. Plus cosine of x, 4/5. Although that we already knew, we could just copy it from here. Sine of y, well, there it is, 12/13. We're already getting that common denominator again. It looks like it's 5 times 13, which is 65. 15 plus 48. So we were at 63 65ths as our answer to this problem. We're going to look at one more, and then I'm going to move this over to a second video. Here we go again. Let's take a look at x's and y's and what we know about them. X is between 0 and pi over 2. X is quadrant 1. Y, however, is between pi over 2 and pi. That's quadrant 2. So y is a quadrant 2 angle. Let's go ahead and take our pieces of information that we know. We've got our x triangle. Sine is 3/5. Missing side, 4. And now we've got some quadrant issues. So I'm going to note this is quadrant 1. We have our y triangle this time. The sine is 12/13. I think we just saw this one. Makes the missing side 5. This one, however, is quadrant 2. This matters when we start looking at the other trig values because we're going to need to know plus or minus. Here we go. We're looking for the sign of a difference. So the sine of x minus y is the sine of the first, cosine of the second, minus, this time the minus carries through, cosine of the first, sine of the second. We should have all the values that we need. Sine of x is given 3/5. Cosine of y, I got to come over here. The cosine of y is 5/13, but it's quadrant 2, where cosine is negative. So the cosine of y is actually negative 5/13 minus cosine of x, coming from triangle of x, 4/5, quadrant 1, it's positive. This minus just carried through. Finally, the sine of y was given to us as 12/13. Just like in the previous problem, it looks like we've got a 65 in the denominator, 5 times 13, and negative 15, and a minus 48. So it's kind of like last one. Negative, though, 63 over 65. And that takes care of introduction and a couple of examples. I'll be back with a second video to give you the last 3 problems.